Yeah, welcome to today's class. Today we want to look at the foundation of what? Data structure and algorithm, right? So far we have done intro to DSA, and we have also seen some standard terminologies in DSA. And I also show you the memory layout of data in the computer. So today's class we are going to look at foundation of data structure, and meaning we've come down to the memory layer. So we are looking at the operations, things that will happen inside the memory, and how data is stored in the memory. So to treat this class, we are going to look at one, data object, right? Two, we are going to look at data types. And three, we are going to look at basic operations. On data. So these are the three things we are going to look at, considering what? The foundation of data structures and algorithm. So without wasting much time, let's begin. Now, before a computer can solve a problem, right, the computer must first store and organize data. Just like the same way you store books in the library for easy access. So a computer must also store and organize data. So this organization of data is basically what data structure and algorithm is all about. So what is data object? That is the first thing we are going to look at. I can define data object as an entity that contains data and is treated as a single unit by what? The system, right? An entity. So in the class of basic or standard terminologies, I explained the meaning of entity to you, and I also explained the meaning of what? Record. So data object is an entity that contains data and is treated as a single unit by a system. Example of data object is what? Student record, employee record, right? Those are what? Data objects. So we are now looking at the objects that are going to live in the memory. So if I say something like student, right? And then I have this. So for student, I will have student name, right? I will have student age, right? And here, maybe department, right? So this is what? Data object. Now, these are the fields, which are what? The data items. So if then age, I can say age, I assign 20 to it, right? This is what? Data, and this is a field name. So this is considered as a data item. Now, all these data items together make up the student, and that is what you refer to as what? Data object. All right. So the next thing is what? Data types. So this actually defines, so it's a classification that tells us the type of data that will be stored in that memory, um, the size of the memory that will be allocated to that data, and the kind of operation that can be performed on the data. That is what these data types determine. So in essence, what data type is what? Data types defines the nature of the data, right? That is what it does. Defines the nature of the data. So based on that, we can allocate memory space to the data. So this data type can be divided into two, right? So we have built-in, built-in data types, and then we have derived data types. Now, this built-in data types is actually is a data type that has been provided by the programming language. For example, you want to buy a house. The house will come with the door, the windows, the roof, the walls, right? So that is a complete house. But if you want to build a house, you are going to start from the scratch using component parts to make that same thing that you bought. So that is how it is here. The built-in data types are provided by what? The programming languages. Then the derived data types are formed or created from the built-in data types. So example of these built-in data types are what? Example of this is what? Integer, right? Which we refer to as int. Now this one is what? Whole number, right? Whole number. Then we have float, right? This one is what? Decimal numbers, right? Then we have boolean, and this one contains true or false, right? Then we also have this again, we have character, which we refer to as what? Char, right? And then we also have strings, right? So if we are going to look at this integer, like this age, so we say int age assign 20. That is, this integer is telling us the type of data that we will store in this field. So that will be what? Integer. Now, I cannot store 20.5 in this place because of this. This is a whole number. Now, float, for float, we are looking at float. We can say height, right? And then we say 5.8. So this is the variable name, which is the field name, and then this is the data that will be stored in it based on this nature, that is the data type, which is what? Float. Then we have bool, right? So so we can say status, and then we say true, right? So this is the data type that tells us what should be stored in this status. So it can only be either true or false, right? That is what should be stored here. Now, these are what? Then we have character. So char, grade. Then we have a, right? Then we have string. So this string, char, name, right? So this one, so that is it. So these are what? Built-in data type that is provided by what? The programming languages. Now, from this built-in data type, we can get the derived data type. So example of derived data types. So example of derived. So this one we are looking at what? Array, right? Now this array, you can say int, right? Int numbers, and then 5. Now, then you can do this. So here I will say 10, 20, 30, 40, 50. I'm closing this because of space. That's why I brought it down. So this is an array. So this is the array name telling me that I'm going to store what? 5 integers. So this is 1, 2, 3, 4, 5. Now, I told you that data type, which is this, is actually what? The nature of the data. And it helps to tell us the memory size that should be allocated to each data. So for integer, it's 4 bytes. Right? I explained that in the last class. So for integer, it's 4 bytes. And 1 byte equals to what? 8 bits. I've explained that in my last class. So you are having how many integers here? 1, 2, 3, 4, 5. So that will be what? 5 times 4, that will be 20. So 20 bytes will be allocated in the memory for this derived data type, that is array. So we also have list as a derived data type, list, right? Example of this is like storing things together, like rice, yam, right? Um, Beans, right? So this is a list of item. Then we have stack. So this stack is using a principle known as what? LIFO. Last in, first out. So you are stacking plates. That is like this. So this is the first one that came in. This is the last one that came in. But this last one is the first one that will go out. So last in, first out. The last one that came in is the first one that will go out. Then we also have queue. This one is using FIFO. First in, first out. So you go to the filling station to buy fuel. The first person that drove in is the first person that is going to drive out. Assuming we have just one pump, right? That is a queue. Or you go to the bank to withdraw money, and then there is a queue. So the first person that came in is the first person that should go out. That is the concept of queue. So these are derived data types from what? The built-in data type. So that is what you are looking at, because you're looking at the foundation of data structure. So the next thing we will look at now is what? The basic operations. What are the things, operations that can be performed on data? So this one tells you the data object, which means entity that contains data. This data type tells you the nature of the data, and that helps to determine the memory size that should be allocated to each data. Now, the basic operations, all right, that can be performed on this data. One, traversing, right? Traversing. So meaning you are able to access individual elements. So practical example of this in real life is what? Attendance, where the teacher is calling the attendance of students in the class. So you call line by line. You call the first person, present sir. Second person, present sir. That is traversing. So we are going 10, 20, 30, 40, 50. So you are able to access 10, 20, 30, 40, 50. So that is traversing, right? So the second one operation that can be carried out on data is what? Search. Searching, right? Practical example of this is when you are looking for contact in your phone book. That is searching. So you just type the person's name and then it will come out. So that is searching. So I can search for 10, I can search for 20, I can search for 30, I can search for 50, right? These are the algorithms we are going to write in order to be able to carry out this operation. So first, you store the data, then you perform operations on this data. So the nature of the data is what will determine the type of operation that you're going to perform on the data. Do you understand? So the third one is what? Insertion. That is insert or inserting data, right? So you have 10, so you have 10, you have 20, you have 30, right? And then you want to insert 40. So before is 10 to 30. After insertion, you have 10 to 40. What kind of algorithm will be written to achieve that? That is also part of what we are going to study. Then we have another one, deletion. Deletion. So you have 10, 20, 30, 40. Let's delete this. So after deletion, we have 10, 30, 40. How are you going to perform that operation? That is also what you are going to look at using algorithm, right? And then 5, we have merge, right? To merge. So you're having different data. So you have the first one, say 10, 20, 30. So this is one data set. Then another one, you have 40, 50. So you are going to merge them. So after merging, you're going to have 10, 20, 30, 40, 50. That is it. So that is merging, combining different data sets. So you're also going to see the algorithm that will be used to do that. Then another one is what? Say 6, you have what? Sorting. We're also going to use an algorithm to perform this task. So what do you do? So you can have something like, you can have 50, 30, 10, 40, 20. So before sorting, the data are like this. After sorting, you will have 10, 20, 30, 40, 50. So that is the sorting arrangement. So these are the things you are going to perform on data. So what we've done so far, looking at data structure and algorithm, is that we've seen how we move from voltage to binary, from binary to data, from data to processing, from processing to what? Information, then to knowledge. So that is basically what we are doing. So how to achieve all those things are the building block that I'm giving to you. So now we've come down to the memory layout. We are looking at data objects, how these data are actually formed and how they are going to live like beings in the memory. So before computer can perform any task, it must first store and organize data. And we've seen what data object is. Data objects are what? Is what? Entity that contains data. And I've explained entity to you, represented by what? Record, right? So when you have, I told you, when you have this, so you have ID, you have name, you have age, right? Now, the first one, this is a record, and that is an entity. So it contains data, right? That is treated as a single unit by the system. So that is basically what this foundation of data structure and algorithm is all about. We have seen data object, we have seen data types that defines the nature. We have also seen basic operations. And if you look at all these things, this is basically what the human life is all about. Traversing, you are looking at your experiences in life, right? Searching, inserting or insertion, deletion, merge, sorting. Many other ones we are going to look at. So that is what I want to show you in this class. In the next class, I'm going to show you the architecture of the memory again. Then we can now move into individual data structures. So if you have come with me this far, don't forget to give me a thumbs up. And if you have not subscribed to my channel or follow me on my Facebook page, please do so. So till we see in the next class. Bye-bye.